Okay, so this is finding the area of a segment. The segment is PQR here, okay, which is that one. So in order to find the area of a segment, obviously you have to do area of sector. The area of sector, remember the formula is theta over 360 times pi times r squared. Theta is this angle here. This is 90. So 90 over 360 times pi times radius. The radius is actually 8 centimeter. Here, to the mark. 8 squared. And we just plug that in and calculate 90 over 360 times pi times 8 squared. That gives you 16 pi. We'll just leave it as pi for now. Then the second one you have to do is area of triangle. Two formulas is half time base times height, or you can do half AB sine C. This angle is 90 degrees because so this is a right angle triangle. Right angle triangle, you can do the easy one, which is half time base times height. Otherwise you have to do, remember, half AB sine C angle. Okay, so this one I'll just do the half time base times height. Half time base, shall we just say the base is 8 and the height, can just say the height was 8. That makes it 32 centimeter squared. Okay, so the area of segment is equal to the area of sector, which is 16 pi. Take away the area of triangle, 32. So you would do 16 pi, take away 32. Answer to 3 significant figure, that should give you 18.3 centimeter. 18.3 centimeter squared. That's the answer. Okay, good. Maybe now. You got a similar triangles. Certain lengths are given to you. They want CB. CB is the longest line from here to here. So what we will do, we will just draw the long triangle. That's the long one, or the big one. And then we'll draw the short one. The long one is actually ACB, remember. And the other one is DEB. Let's put the lengths in there. A to D. A to D is 9. So this is 9. Okay. D to E. D to E is 2. That's 2. D to B is 6. D to B is 6. Cool. So A to B. So what is the total of A to B then? That's 9 at 6. That makes it 15 then. That's 15. This is 2. We got that. And D to B is 6. They told you that. No, so that's fine. What do we want? We want to find out the length of C to B. So I want this one. Okay, can I work this one out? Because if you look at it, these two are similar lengths. So if I say this 15 is the same thing as that. The CB, you don't have the EB. So what we could do, can you see this 2? We can actually figure this one out. So let's call this X. Okay, so remember, okay, I will do this length here divided by that length. That is equal to that length divided by that length. It's just a ratio. So if I say 15 over X is equal to what's that? Remember, 6 over 2. Okay, remember, if you do this one divide this one, then it's always that one over that one. Okay, remember. We can cross multiply this. That gives you 30 equals 6x. If I do x, x is equal to 30 divided by 6, which is 5. So x is 5. Now, I still need to do CB. CB, because I know this is a right angle triangle, I can do Pythagoras. CB is the shorter side, so square root of 15 squared, take away 5 squared. CB is equal to 10 root 2. But obviously they want it for 2 decimal places. Let's see. So it's 14.14 centimeters. That's your final answer. Okay, maybe not. Okay, let's look at this one. Directly proportions. Direct and inverse proportion. So first line, it says x is directly proportional to square of y. Directly proportional means k times x is equal to k times y square, square of y. Cool. Next one. X is equal, y is equal to the question, second line. Y is equal to directly proportional k times cube of z. So that is z cubed. Cool. Right. We only have 2 things in here. So let's just substitute it. Doesn't matter. X is equal to 32 equals k. K is we don't know, y squared times y squared. Okay, y is equal to what? We don't know. Y is equal to k times z cubed. Z is 2 cubed. 2 cubed is 8. Y is equal to k times 8, that's 8k. Now what you will know, these two k's are not the same. Okay, so we would just, let's assume that this k is a different letter. That makes life a lot easier. So let's so instead of k, just come up with another letter. Shall we say p value? Okay, just put p here, doesn't matter. P, that makes it 8p. So k comma p are what we call constant, like numbers. Normally I would tend to say kk, but then I would work out the two different k's values, but we'll just leave it here. But then okay, what you will notice is x in terms of z. So if you look at the formula, this is your first formula, this is the second formula, x in terms of z. So x is equal to k times y squared. Y is a common one, so just substitute. Y is what? pz cubed. But that is y, remember, pz cubed is y, so you square that because it says y squared on the side. So x is equal to, if you're going to k p squared z to the power 6. But can you see, I need to know what is kp squared is, otherwise it's in terms of not only z but also k and p. Okay, so I need to know what z is. Very simple. Kp, so y, so k is what value? Okay, let's see my k value here. Oh, okay, so we got this up to here like that. Okay, you know what, we got this far. What we could do, just substitute the value. So you know, the up to here we can just substitute x is what, 32 again on this one, just substitute it, equal to k p squared z to the power 6, that is 2 to the power 6. 2 to the power 6 is 64. So what is kp squared is? Kp squared is 32 over 64, which is just a half. So x is equal to kp squared z to the power 6, but we know what kp squared is. It's a half z to the power 6. So there's not really a requirement to do these. Okay, you could do it and then resubstitute it and find that, but it's easier to substitute it already onto the question straight away like that. Okay, so x is equal to, that's the final answer, half z to the power 6. Okay, moving on. The curve has an equation of that. The curve, okay, the line is that. Show that only one common point. So all right, let's say, so this looks like a simultaneous equation. They're going to intersect, blah blah blah. Think about it. So in order to do quadratic simultaneous equation, we can do y equals to y. We already know y here, but we don't know the y here. So make it the subject. Y is equal to, bring the minus 5 to the other side, plus 5x minus 4. Okay, we now could say y equals y. Let's write the first one. X squared plus 3x minus 3 equals to, what's the other y is? 5x minus 4. Bring it in. X squared plus 3x, bring this in, minus 5x, that makes it minus 2x. Minus 3, bring that in, plus 4, that makes it minus 3 plus 4 is plus 1, equal to 0. X, if I want to factorize 1, factor the 1 and 1. You want minus 2, so minus 1, minus 1. X minus 1, x minus 1. No. So technically speaking, it looks like that, doesn't it? Because it's square. So x is equals to only 1. Show algebraically that C and L can have only one point in common. Okay, if you look at this one, how many points is there available in terms of C and L? It's just one singular point itself. Okay, so x is the only solution. That's it. Normally, sometimes you will see two answers, you know, quadratic formula. So there is only one solution for the intersection. Okay, maybe not. At the start of the year, population, remember iteration questions. The key is, let's write the, so this is the formula. Cool, another formula now. Very good. So 2017. Next one is 2018, 2019. Do they do it tomorrow? No. The number of population is 4,000. In 2019 is 3610. Cool. And then if I look at it, p values, shall we start p note, p1, p2? Cool. In here they just want you to work out the k, that's it. You're not doing like, you know, p3, p4, p5. Just need to find the k, that's easy. We don't start with p0, remember we start with the p1. P1 is equal to, if you look at it, p1 is equal to k times p naught, kp naught. Okay, then I'm going to write p2 is equal to k times p2, remember. Okay, let's, okay, I've done my working out. What is p1 is? P1, no idea, because the years are not an issue. I'm just going to cross the years off. P1, do I know the number? No idea. P1 is equal to k times p naught. What is p naught is? P naught is 4,000. Can you see? P naught is 4,000. So P1 is 4,000 K. P1 is 4,000 K. Got it. Sorry, P2 is K times P1, by the way, yeah? K times P1. Okay. P2 is equal to 3,610 is equal to K times P1. What is P1? I know, 4,000 K. If I multiply 3610 equals to 4,000 K squared. What I'm trying to find the K, right? K squared equal to 3610 divided by 4,000. If I simplify this in my calculator, 3610 divided by 4,000. 361. Okay, it doesn't simplify as much. You can just cancel these zeros. It's over 400. K is equal to just a square root of that, 361 over 400. If I square root that, that will give me 19 over 20. And that's K. Okay, so they want you to find the K, and that's equal to your K. K is equal to 19 over 20. That's your answer. Very simple 3 mark. Moving on. Okay, show that it can be written like that. So if you look at it, let's sort out the division sign first. Division means 6x cubed over 9x squared minus 144. Division becomes multiplication, and the second fractions just, you know, turns out becomes a reciprocal itself. 3 bracket x minus 4. Okay, let's keep it like that, over 2x to the power 4. Now I can see, okay, can I, is there a quadratic? Yes, there is. This is a quadratic one. You can simplify this guy. So what is that going to be? Okay, 6x cubed. Remember, 9 is 3, x squared is x, is a difference of squares, so minus 144 is 12 squared. The other one is 3x plus 12. Remember, it's a plus and a minus because difference of squares. If you look at it, this one, if I expanded it, it should look like something like that. So let's expand this. 3x minus 12. Let's put a bracket. 2x to the power 4. Okay, I can cancel this one and this one. Cancelled. What else? 2 get cancelled with 6 and will give you 3. X cubed and x to the power 4 cancel, only leaving you with an x. Okay, so if I multiply, there's no number here, so it's automatically 1. So 3 times 1 is 3 over 3x plus 12 times by x. If you look at it, I can take what inside the bracket common, 3 common, so 3 over 3 common, and let's put the x next to it. And if I take 3 common, that gives me x plus 4 on there. 3 and 3 can cancel, makes it 1. Answer is 1 over x plus 4. Okay, so it can be written in that form. Technically, r is being that 4 in that case. Okay. Okay, moving on. Cool. These would be non-calculated, by the way. So if you look at it, 81, you're rooting it to the 4. So what number can 81 be written as? 3 to the power 4 is 81 times 10 to the power 8. Okay, that's all right. If you're doing it to the power 4, what I can do, I can cancel this guy and then divide everything by 4, because this number I'm trying to divide it by. So divided by 4, divided by 4, that makes it 1. If I divide it by 4, that makes it 2. and the square root goes away, by the way. 3 to the power 1 times 10 to the power 2. What is 3 to the power 1 is 3. 10 to the power 2 is 100. So my answer is 300. I don't know the negative of it. So I could do the positive, just positive one. 64 to the power a half. To the power half means square root, remember 64. You know that's 8. But if it's a negative power, you have to do the reciprocal of that. What's that? 1 over 8. So the answer is 1 over 8. And this one was 300. Yeah. Next one. 3 to the power n. Okay, that's fine. As a power of 3, it's fine. But 9 to the power, that's not as a power of 3. So 9 is 3 squared to the power n minus 1. If you have a bracket and that automatically means you're multiplying it. So 3 to the power n over, if you multiply 3, 2 times n is 2n. 2 times 1 is minus 2. A lot of people just put minus 1. Don't be that guy. Okay. Then that is equal to, let's put equal here. 3 to the power n divided by 3 to the power divide, because it's a fraction, right? 2n minus 2. 3 to the power n, take away, I'll put it in a bracket, 2n minus 2. Because you're doing it with the same powers, same bases, you can kind of subtract the powers. 3 to the power n, take away 2n plus 2. That makes it 3 to the power n minus 2n, that makes it minus n plus 2. Okay, so that's okay. Some people would like to write it as 3 to the power 2 minus n, but that's your problem. Okay, moving on. A straight line. Okay, that's that. It's perpendicular, so we need the gradient, and we know the point, so that's good. So we need the gradient. What is the gradient of this one? Y equals to 3x minus 4. We can do the gradient or not? Yes, it has to be written as y equal to. Yes, it is. So it's fine. What is my gradient of this guy is 3, but I don't want this. I want the perpendicular one. What is the gradient becomes now? Remember, perpendicular means you have to do opposite signs. So positive, so it's negative. You have to flip the fraction over 1 over 3 then. That's my gradient. Now, what is my coordinate 9, 5? What's the common formula? Y equals to mx plus c. Y equals to ms minus 1 over 3. X plus c. Let's substitute this. Y is what, number 5 equal minus 1 over 3. X is 9 plus c. Multiply everything by 3 times 3 times 3 times 3. That can cancel. 15 equal minus 9 plus 3c. 3c is minus 9 become plus 9. So 15 plus 9 is 24. C, if you do that, C, how much is it? 24 divided by 3, which is 8. Y is equals to, what's the equation was? Minus 1 over 3 x plus c. Y equals to minus 1 over 3 x. C is, you know that, 8, so plus 8. That's your final answer. Okay. Moving on. Cool. That's it.